Hello everyone. In this video, we are going to discuss about the problem on the turning movement diagram for a multi-cylinder engine. Okay, so in the previous class, we have discussed about the similar problem for a petrol engine. The similar data was given, but the only difference is in the previous problem, we was asking to find out the coefficient of fluctuation of speed when the radius of gyration was given. Okay, but in this problem, he is asking you to find the mass of the flywheel at a radius of 0.5 meters. Okay, so before continuing this problem, so I would like to give you the two equations which we know, that is delta E is equals to mk square omega square cs, and also this delta E can also be written as m r square omega square cs, right? So this relation we were using in the previous problem, and this relation we are going to use in this present problem, because the only difference is in the previous problem he has given the radius of gyration k, and in this problem he has given the radius of the flywheel, that is capital R, which is equals to 0.5 meters. Okay, so in this problem, by using this data, we are going to find out this mass of the flywheel, right? So now let us continue the problem. Right. So first of all, let us write down the given data. So in the given data, he has given the scale for turning moment and as well as for the crank angle. Okay. So for turning moment, the scale given is 1 mm is equals to 600 Newton meter, and for crank angle it is given as 1 mm is equals to 3 degrees, right? So as we already discussed that this data is used for converting the maximum fluctuation of energy into the actual units of Newton meter. Okay, so we'll use this data there. So for that purpose, what we have to do is we have to multiply this 1 mm into 1 mm is equals to, this will give you 600 into 3 degrees, or 600 into, so now this 3 degrees should be written in terms of radians, that is 3 into pi by 180, then this will be equal to, so 1 mm into 1 mm is 1 mm square, so this value will be 31.4. 31.4 Newton meter. Okay, right. So then in the further, he has given some areas here which are positive and as well as negative. So that means plus sign represents the areas above the mean torque line, and minus represents the areas about the, I mean below the mean torque line. Okay, so these areas, by using these areas, we are going to find out the delta E. So before finding out, let us draw the turning moment diagram as per this diagram here, as per this given data. So first it is plus 452, then minus 24, plus 92, minus 140, plus 85, minus 72, and plus 107. Okay, so this is the turning moment diagram for this as per this data. So let us say this is A, this point is B, this is C, D, E, F, G, and this one H. Okay, so let us find out what is delta E. So before finding out what is delta E, let us assume the energy which is available at A is equals to E. Okay, the total energy which is available at A is equals to E. Then the energy at B will become E plus 52 because the energy at B is plus 52. So it will become E plus 52. E plus 52. Then similarly, the energy at C is equal to this E plus 52 minus 124. E plus 52 minus 124. Okay, so this will be E minus 72. Right? Then next, the same energy at D will be equal to this E minus 72 plus 92. So that will be E plus 20. Then energy at E will be equal to E plus 20 minus 140. So that will be E minus 120. Then similarly, the energy at F will be equal to E minus 120 plus 85. So it will be E minus 35. Right? Then energy at G. This will be equal to E minus 35, E minus 35 minus 72. So that means it will be E minus 107. Okay, then finally the energy at H will be equal to this E minus 107 plus 107. So that is will be equal to E minus 107 plus 107 will get cancelled, then we'll get E. So again with this E is nothing but the energy which is available at A, right? So now from this data we are going to find out what is delta E. So we know that delta E is equal to maximum energy minus minimum energy. Okay, so what is maximum energy from this data here? Which is having the highest positive value. That means this one. This is having the highest positive value. And what is the highest negative value here? This one. This one is having the highest negative value. So this will become the minimum energy. Okay, so maximum energy minus minimum energy will give you this maximum fluctuation of energy. So that is E plus 52 minus E minus 120. So that means plus C minus E will get cancelled. Then 52 plus 120, that will give you 172 mm square. So as I told you, this delta E should be in terms of Newton meter. That means we have to use this data here, this one. So 1 mm square is equal to 31.4 Newton meter. So substitute here. So this will become 172 into 31.4 Newton meter. So then this will be so this will be 5,400.8 Newton meter. Okay, right. So but delta E is equal to mr square omega square into Cs. Okay, so we know delta E, we have just determined it. Okay, so R is given, radius, how much it is? 0.5 meters, and omega we can find out by using 2 pi n by 60, which is equal to 2 pi into, the speed is given as 600 rpm, so 600 by 60, so that means 2 pi into 10. So 2 pi into 10, so which will be 62.8 radians per second. Okay, 62.8 radians per second. Now substitute all these values in the above formula to find out the mass. That is delta E. So therefore, delta E is 5400.8 is equals to m into 0.5 square into 62.8 square into CS value. So how to find out the CS value? Here you can see he has given that if the total fluctuation of the speed is not to exceed plus or minus of the mean speed. Total fluctuation means omega 1 minus omega 2 by omega will be equal to plus or minus of 1.5%. That means it is plus or minus of 1.5% means it is 3%. So which is equal to 0.03. So the value of CS, this is CS. So the value of CS is 0.03. Okay. So substituting that here, 0.03. So this is how you have to find out CS. Okay. Right. So from this, we are going to find out how much is mass. So, so the mass of the flywheel, so the mass of the flywheel will be around approximately 182.5 kgs. It will be 182.5 kgs. Okay. So I hope you have understood this problem. Okay. So it is very simple problem. So it is very similar to the previous problem. In the previous problem, he has asked to find out the coefficient of fluctuation of the speed, okay, with the radius of gyration given. Whereas in this problem, you have to find out the mass of the flywheel if the radius of the flywheel is given. Okay, so that is the only difference between this. So we'll continue the next problem in our next session. So thank you, everyone.